Hi, I'm Adam Vogel, and I'm the president of the Rocketeers of Southern Illinois.
Hi, I'm Pedro, and I'm the vice president of the Rocketeers of Southern Illinois.
Hi, my name is Vidalis, and I'm the treasurer of the Rocketeers of Southern Illinois.
Hi, I'm Rebecca, and I'm the secretary of the Rocketeers of Southern Illinois.
This will be our second year of competition at the Argonia Cup. After a second place finish last year, we are eager to win. Aside from a few small cracks in the fins, our rocket from last year was in perfect condition. Last year, our rocket flew to 12,000 feet and earned us a second place finish. Since we will be attempting to use a drone for the first time, we want to keep as many constants as possible. We will fly the same 4-inch rocket as we did last year, in the same configuration, to give us the most consistency while we program our drone to fly.
The outer appearance of the rocket will remain unchanged, with all of our focus on its internal components. This year, we are implementing a more sophisticated tracking system, higher quality camera, and of course, our competition drone. Teams in the past years have attempted to use small quadcopters to deliver the golf ball, but didn't have success. We began fall semester by attempting to build our own quadcopter, but quickly realized that it was much more complex than it needed to be. In theory, our drone does not even need to be able to fly vertically, it just needs to be able to control its descent. However, without any of our team members having experience with model aircraft design, we didn't know where to start.
As we were about to scrap the drone idea altogether, we managed to get in contact with the CTO of Mayan Robotics, one of the leading hobbyist autopilot manufacturers, who was excited to help us develop a drone. After a few weeks of thinking, we agreed that ditching the motors in favor of a gliding aircraft would be optimal. This allows us to use a significantly smaller battery, less wires, and no propellers to protect during ejection. His company worked with our team to produce a 3D printed glider capable of withstanding 25 Gs. Guided by a GPS and other electronics, the glider will be ejected at apogee and then fly itself back to the ground completely autonomously.
The process of ejecting the drone from the rocket appeared to be a daunting task, but ended up having a somewhat intuitive solution. After a few weeks of prototyping various methods of ejection, we decided that extending the bottom of our avionics bay with 2 rigid rails sealed on the bottom by an additional, taller bulkhead would be best. This allows the drone to be pulled out in the same process that ejects the payload bay from the booster. And, with foam cushions on the top and bottom, there is no risk of breaking. After a few static tests, we became confident in this method of ejection.
Now let's talk about the rocket itself. We decided to name our rocket Montemagno after our university's former chancellor, Carlo Montemagno, who passed away last year. His passion and enthusiasm were crucial to the formation of our club and its quick rise to competition on a national level. The Montemagno is a 4-inch diameter, 8-foot tall rocket. It will be carried into the sky by 4,616 Newton-seconds of impulse, delivered by an Aerotech L1420. We predict that with the added weight of our drone, the Montemagno should reach just under 12,000 feet at a max speed of Mach 1.15. After reaching apogee, the payload and booster sections will be separated by 3 grams of 4F black powder contained in our ejection charges. They will remain tethered together by 3/8-inch Kevlar shock cord. Once the rocket reaches 800 feet, we will separate the nose cone from the payload section and release the main parachute.
The deployment will be controlled primarily by a telemetrum altimeter that we won last year with a redundant perfect flight stratologger for safety. Using the telemetrum's GPS transmitter, we should be able to track and locate our rocket much faster than last year when we used a falconry tracking system. We will still use the falconry tracking system to locate our drone should it land somewhere other than the target, due to the small size and weight of the transmitter.
If everything goes as planned, this will be another successful year for our team. We wish all the other universities the best of luck, and we look forward to competing at the end of March.
Go Dogs!